Hello, I'm Kevin Ripp, aka the Bugman. I'm the Director of Science and Innovation at Aquafix. I manage our wastewater research laboratory, which is located in the University of Wisconsin Research Park. In our lab, we get samples from around the country. In fact, we get samples from around the world, and we've gotten samples of wastewater from every continent, including Antarctica. Customers will ask us, they'll be having biological issues, and they'll ask us, can you tell us what the problem is? Either it's not settling, or they're having problems with their sludge, or sludge dewatering, or they're having odors, or high effluent ammonia. It could be a number of things, but they asked us to get to the bottom of it and solve the problem. So we collaborate with these wastewater plants to dig deep on their behalf, so we can both understand the problem, the process, and how we can improve the situation. In this process, we develop biological science products, and we'll feature a few of these in this PowerPoint. Note that each of these biological science products is about 5 to 7 years in the development. The development of these products takes quite a bit of time. What will be covered today? Number one, an overview of toxicity. We will look at all the types of toxicity. We will narrow in on a quaternary amine and some of the studies we've done then. Then we're going to talk about recovery from toxicity. We'll talk about toxicity with temperature change. We will do testing on Quat binding products, testing on our new CounterQuat, and we will study recovery from nitrification after toxicity. Here's some stock ciliates. And what we did, just to visually show you what's going on with Quat, is we added Quat on this side of the cover slip, and we created a current so the Quat washed over these stalks. So you can see when we take the Quat and we start creating a current, so the water goes by the stalks, you can see what happens to them. The toxicity, whether it be Quat or PAA or anything, this is what they do to the organisms in the mixed liquor. What are the causes and contributors to toxicity? Well, we have acute toxins. This could be like reduced sulfur compounds like hydrogen sulfide. Hydrogen sulfide not only is a strong gas, but it's an oxygen scavenger. So H2S can take DO out of your plant. Bleach, quaternary amines like we're talking, peroxyacetic acid, and it would be fitting, since this is the time of the coronavirus, triclosan, which is in hand sanitizer, is something that's also a toxin. There's severe toxins like heavy metals. In addition to toxins, sometimes it's the toxins plus the stress on the system that causes the issue. We can get rapid changes in temperature, pH, changes in operation. That, in addition to something else, can cause the problem. What are the symptoms? First of all, high effluent TSS or turbidity, loss of nitrification, loss of protozoa and metazoa, disintegration of floc, diffused EPS in the bulk liquid. We'll talk a lot about EPS in this presentation, and poor BOD removal. Some of our solutions we'll feature here is our CounterQuat, which builds bacterial polyprotein matrix, our Smart BOD, which is a balanced carbon source, and our nitrifiers. So what are quaternary ammonium cations? Some people will call them QACs, some people call them Quats, some people will call them quaternary amines. They are used as disinfectants. They are biocides. It's a very stable molecule. Why study toxicity, specifically Quats? Toxicity is a concern in meat packing, rendering, food processing, or institutional wastewater processes. It's also a concern in municipal operations that get industrial discharge. Quat binding products have not been found effective. Information learned about our Quat toxicity can be applied to other forms of toxicity. And the presence of Quats in wastewater is very difficult to test for. Here is a Quat molecule. What it does is it punctures the bacteria cell wall, and then all the fluids of the bacterial cell drain into the mixed liquor. What makes Quat an especially good biocide, it's a very stable molecule, so it can puncture thousands of bacteria cells. So this is first how we study acute quaternary amine studies. Let me tell you, every study we done is done in triplicate, okay? And often we'll do it in triplicate and then we'll do it a couple times. But this is a sample of 30 minutes settling. You can see the cloudy supernate on the top. That will give you a cloudy effluent. Testing is run for 18 hours on orbital shaker plates. Temperature is 72, 22°C. In this testing, we used municipal dairy waste from a cheese plant, and we used an in-house mixed liquor. All our testing was done using a MultiQuat 455 as a standard product. Note that we are a lab, so all of our data is not perfect, and you will see this in this presentation. When you manage a lab, you always get unpredictable things, and as a lab, we report the truth. So here's the percent ammonia and COD reduction with 3,000 part per million mixed liquor in a municipal mixed liquor sample. Here's 10 ppm. At 25 ppm, you can see the nitrification starts to go down. At 50 ppm, we get some real damage. COD removal is less, and you get no ammonia reduction. What also happens when you add Quat is you get a cloudy effluent. So we measured percent change in suspended bacteria. We do this by measuring optical density. And you can see at 15 ppm, all of a sudden the amount of suspended bacteria goes way up. At 30 ppm, it goes way up in both 3,000 and 2,000 mixed liquor. Notice a higher mixed liquor, you get more cloudiness. Percent ammonia reduction in a municipal mixed liquor sample. Here's a control. We have 3,000 and 2,000 part per million. At 15 ppm, the percent of ammonia removal goes down. At 30 ppm, it goes down faster. We feature both 2,000 and 3,000 part per million mixed liquor because as operators, we're always wondering, where should we run our mixed liquor? We have to run it high enough so we get good nitrification, but we don't want Nocardia and Microthrics. So we have to balance that. But here's the effect of toxicity on a 3,000 and a 2,000 mixed liquor. Acute Quat toxicity on cheese samples. So not only do we study municipal mixed liquor, we studied mixed liquor from a cheese sample, okay? So this is COD reduction, and here's ammonia reduction. 15 ppm, you notice how it goes down. Now suddenly at 30 ppm, it goes up. That doesn't make any sense. Again, this is done at triplicate. It's probably done in triplicate 2 or 3 times. Why this happens, we do not know. But as a lab, this is what it gets. It doesn't always make sense what goes on in a process. So those of you who run wastewater plants, it doesn't always make sense. What do we conclude from doing these acute studies? Quaternary ammonia are more toxic to a cheese than a municipal. Higher mixed liquor exhibited less toxic effects. We probably know that. High effluent TS and ammonia are always the first signs. So why would a cheese plant be more toxic than a municipal plant? That's a good question. We believe it's due to the diversity of bacteria in a municipal plant, and they have less diversity in a cheese plant. This causes the toxicity to be more lethal in a cheese plant. Then we studied recovery from toxicity. In these samples, we dosed at 50 ppm of Quat. Samples were analyzed for ATP. ATP is how we measure bacterial activity. COD, ammonia, optical density, which tells us how cloudy the supernate is, mixed liquor, and 30-minute settling. Samples were fed daily with an autoclaved influent. Testing was run with municipal samples and dairy samples. So this is flock. So what is floc? Floc is a grouping of bacteria, protozoa that stick together. They stick together through a glue that's called EPS. It means exocellular polymeric substances. EPS is what allows bacteria to stick together. Okay, so this is a good floc. Everything sticks together. You see we got a few filaments in the floc, but that's normal. But everything is sticking together really well. After we add the quat, notice what happens to the floc. This is after 24 hours. The glue, the EPS, is broken up and the floc starts to break up. This is what gives you a cloudy effluent. Then we looked at stalk ciliates, before, after. We already showed that video. You can see what that does. We took the municipal sample, added quat. The ammonia went up to about 17.4 ppm. After about 7 days, this municipal sample in a lab recovered on its own. We took a cheese plant sample, did the same thing, added quat. And you can see after 10 days, the ammonia kept climbing and it has not recovered. In a system like this, they would use our VitaStim nitrifiers to recover. What are the conclusions from recovery? We notice it's faster municipal than in cheese plant. Microscopic observation showed increased pen floc and reduction in metazoa and protozoa. Recovery of nitrification was slow, especially in our cheese plant samples. Then we looked at quat toxicity and temperature change. As I said, it's often not just the toxicity, it's the toxicity in combination with another environmental change. These reactors were acclimated to room temperature at 1 month. Then quat was applied at 5, 10, 20 ppm to a 3,000 part per million MLSS and put on an orbital shaker plate inside a cooler and set to 7 degrees Celsius. We use ATP to measure bacterial activity, and then after about 1 week, we use for a recovery period. The reactors were fed daily to aid in the recovery. So here's the control, 5 ppm, here's the shock, here's the recovery, 10 ppm, you can see the recovery is way down, and 20 ppm, there's no recovery. So then we said, how does toxicity, or in this case quat, affect oxygen levels? Okay, so we ran oxygen uptake tests. Oxygen uptake tells how much nutrient removal rates are impacted by quats. In this case, we used 100 ml of cheese plant mixed liquor and 200 ml of cheese plant influent. This is a graph of dissolved oxygen. Bacteria use dissolved oxygen as they respirate. This is what the control looks like. You can see it's using oxygen. So the oxygen goes from up about 5.5 down here to about 1.3 in the course of 65 minutes. After we start adding the quat, there's less oxygen uptake. The bacteria aren't using the oxygen, right? Here's the 5 ppm. Okay, there's less oxygen uptake. They're not using the oxygen. Proof that they're dying. There's that graph again. We observed decreases in oxygen uptake with all QAC dose rates. This indicates total treatment time would need to be increased about 65% to accomplish full COD removal in our sample at 5 ppm of quat in this instance. So for years, we've looked at quat binding products. We probably started studying these 5 years ago. And we had a bunch of different tests. A lot of times we would mix the quat with the quat binding product, would leave it sit for 15 minutes and then put it in the mixed liquor. We had a bunch of different ways, but we wanted to test these and see how well they did. We tested 2 marketed quat binding products and both the results were similar. So here's the control. We had about 5% ammonia reduction. Then we took one where we blended the Quat with the Quat neutralizer, 10 ppm of Quat neutralizer. And the ammonia reduction had dropped to about 5%. Then at 30 ppm, all of a sudden it's even, and at 60 ppm of Quat neutralizer, then it showed a benefit. It showed it a really nice benefit. So what we learned from Quat neutralizers is not that they don't work, but they take very high dose rates relative to the Quat for visual impacts to be observed. We supplemented nitrifying bacteria upset, okay? So then we started to look at nitrifying. How does toxicity affect nitrification and how do we recover? Okay, in this case, we did a one-time dose of 20 ppm. Here's a sample. Quats were added. The ammonia went just above 6. We waited a day, added our nitrifiers. We call them VitaStim nitrifiers or VitaStim Dynamic Duo, refers to the two products we use. And then immediately you can see how the ammonia recovers. And without it, it took longer. Again, this is in a laboratory setting. Then we look at loss of nitrification in the field. What kind of examples of toxicity and recovery do we have in the field? So we had this 300,000 gallon per day mixed liquor from a municipal wastewater plant. They had lost nitrification because they had 7 55-gallon drums of diesel fuel spilled into their plant. Their mixed liquor was 13 degrees C. It was cold. The effluent ammonia, as the diesel fuel was breaking down, slowly creeped up to 6 ppm. We used our VitaStim nitrifiers and assimilators, what we call the dynamic duo. In 1 week, they lowered it to 0.2 to 0.3 ppm. Through all of this study and the study of the Quat binding products about several years ago, we started the development of our CounterQuat. We said, how can we improve bacteria's resilience so when they get hit with toxicity, it doesn't phase them? This is our CounterQuat. This builds bacteria natural polyprotein matrix so that the Quat or other forms of toxicity cannot penetrate the cell membrane. So what's the polyprotein matrix? We're referring to the EPS, which is the glue that holds the flock together. And what we do is we put more protein in that glue. The glue is a combination of sugars and proteins. And we add more protein to give the cell, to give the structure more strength. This is not a Quat binding product. This improves the microbiology's resilience to toxicity and promotes recovery. So here's a sample we hit with Quat. We measure bacterial activity in terms of ATP. It goes down, and after day 5, it starts to recover. The same sample, we use our CounterQuat, and you can see when we add the Quat, it just stays right on course. Operators want to know, well, how does this impact me? So here's a sample of mixed liquor where we had the Quat, and we showed a slide some of this earlier. You see I have a dispersed flock structure. Here is the same sample we added Quat to, but we add CounterQuat into the mixed liquor at all, and it strengthens that polyprotein matrix, that EPase around the edge, and that keeps the effluent water clear. So this is Quat plus our CounterQuat. Oftentimes we do India ink stains to see how healthy the EPS is. In this case, you can see how the India ink stains the supernate like a black color, but the flock is very white. The white flock means the flock is very diffuse. It's very unhealthy. But yet with our CounterQuat, the flock remains healthy. This means the flock and the EPS is very healthy. In preventing toxicity, we really look at 2 things. One, we look at, how do you manage the plant? What can we do to make the mixed liquor more healthy? Sometimes in industrial processes, that's balancing the nutrients. We do systems management. We help people in how they manage their process. Where should they keep their mixed liquor? How should they run their plant? And then as operators, we always work to communicate with the upstream people, the people inside of the plant or inside of the meat packer to provide a more consistent discharge of anything that might be toxic coming downstream. This is an example of one of our products we use when a plant has low food. We use a product called Smart BOD. Smart BOD is a dry product. It's a very concentrate food. It's a balanced source of macro and micronutrients. We started this product because we get a lot of plants that are over-designed and they have low incoming food. And this provides a very balanced food for them. It provides balanced, where if you just add sugars, all you do is add sugars. We want to add a balanced source of nutrients to this plant. Some people who use dog food will find out if they use 100 pounds of dog food, they can use 1 pound of this. We have a study on our website done by University of Wisconsin, Stevens Point, that shows how well Smart BOD does compared to like dog food and glycerin and some other things. Our CounterQuat, as we talked about, builds bacteria's natural polyprotein matrix. It works on all forms of toxicity. We've had successes around with all forms of toxicity. And then when people have problems nitrifying, they use our dynamic duo. One of those products is our VitaStim ammonia assimilator. Again, all of our products are sold all around the world. This is concentrate nitrifying bacteria to reseed a plant that's having issues nitrifying. It's a very potent product. It gives very fast results. If you want to read more, you can see our website, teamaquafix.com. You'll see a lot of blogs devoted to some of the studies we see through at our lab. One of them is called Understanding and Treatment of Quat's Interaction with Wastewater Plant. We've given presentations on this around the country. So we are Aquafix. If you have any problems, any questions, you can email us at info@teamaquafix.com or orders@teamaquafix.com. 888-757-9577. Thank you very much for your time, and thank you all you wastewater customers for challenging us. Thank you so much. Have a great day. Bye.